Yes. That's like red versus blue.
So, you watch a lot of YouTube that I watch.
Uh-oh. That's,
You nerd.
so what you got?
Okay, 6.1, number 12.
Should have done this earlier this semester, or tried to make references and see if you don't get them.
Oh. 4 versus west grade is 12. Alright, so this is number 12, 6-1. 4x plus y squared equals 12. Y equals x. So those are your boundaries, or x equals 1. Sketch the region enclosed by these curves. Decide if it's dx or dy. Blah, blah, blah. Okay. So already you should know which way you probably want to go with this. All right, so let's do this one step at a time. So I'll sketch the region. What do I do first? Before I...
The bounds are.
True, and how do I do that?
So they're equal to each
So
other.
yeah, use them together, right? So in this case, I know that y is x, so I can just use that information up here. Right? Either way I want to. So do you want to replace x with y or y with x? Y with x. Okay, so this will become, so if I plug this in here, 4x plus x squared equals 12. Right? So this is me trying to figure out where these meet, so I know, like Ricardo said, my bounds, my limits. It's good to know your limits. What do I do with that?
Bring the 12 over.
Bring the 12 over.
Yeah.
Maybe put it in order.
And then back to
No. Yeah, so we got x, 6 and 2 will make 4, and of course, which one's positive?
6.
6. So you get blah, 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 blah. You get 2 and negative 6. Now, that's not good enough. What do we want to do with each of those?
Plug them in to see what the y
See what the
is.
points are, but the points are going to be silly because x equals y. Right, so whichever one you put 2, if I put a 2 in here, well, let's see. So x equals y. So I get 2, 2, negative 6, negative 6. Real quick, if I put a 2 in here, I get y squared equals, so this would be 8, subtract, you get 4. I get plus or minus 2. You guys agree with me? But of course, this other one requires that x equals y, so I can't use negative 2. And a similar thing will happen if I put a negative 6 in there. Okay, I really want you guys to be with me. So it shouldn't matter which equation you plug these into because they're supposed to be where they meet. So they're going to both give you the same information. Okay? All right, so let's use that to make a sketch. Oh my God. 2, 2, negative 6, negative 6, negative 6, negative 6, 2. Y equals x. Yeah. Okay, make that big, make that big. Pretend like this straight. And what will this one look like?
Parabola that opens sideways.
Sideways, I like it. So all I really need to know is, for example, if I make y 0, what would x be? I really want you guys with me. What am I trying to do right now? What's the most important thing to know? I know it's parabolic, but what really matters is where it is in relation to this line in this region, right? Because then I can know which one's on top, which one's on the bottom, all that kind of stuff, right? That's what's most important. So when I plug a 0 in, for example, for y, what do I get for x?
Negative
3. So when y is 0, x is 3. So then it's going to look like this, roughly. I don't care where the vertex is, right? The point of this problem is not graph this parabola. The point of this problem is find the area. And what's the only thing I care about when I have the 2 intersection points is, one, what side is the other function? And because I want you, because some of you guys are like, man, earlier this semester you were kicking the shit out of me with the graphs I was doing. Because then the point was the graph, right? Then you better be freaking specific as shit, and I mean specific, like the curvature better match what it, right? Here, who gives a shit? It's not the point of the problem. I just need a little visual anchor, right? So, do you guys know, should this be integral dx or integral dy? Why? Sure, I like it. Everything's, and you could solve this one for x, but it would be a little bit grosser to solve it for y. Right? You guys good? I really. What would happen if I solved this for y? What would happen? What would show up?
Square root.
A square root and plus or minus, right? So if I try to do it in terms of x, I would draw a triangle in here, right? I would draw a triangle here, and I would draw one here on this side, and they're between two different. I don't want to do it in terms of x because at some point the walls change, right? But if I do it in terms of y, the walls are always the same. This wall is the line, and this wall is the parabola throughout the whole region. You guys see that? Okay. So what is the height of this rectangle? So what's this one going to be? I have to solve that for x, right? So if I solve that for x, what do I get? I get 12 minus y squared over 3, otherwise known as 4 minus 1/3 y squared. Is that correct? So how tall is this rectangle? What's the top of the rectangle?
4 minus 1/3.
4 minus 1/3 y squared.
Minus 1.
Minus, this is just y. Is that cool?
Why is the parabola top function? Oh, because it's a y, got it, yeah.
Yeah. So it's always, the top is always the one that's more positive.
Mhm.
The bottom is always one that's more negative. So when you're doing in terms of y, just literally just do this, or take your paper and do that. Oh, top, bottom, yay, right?
Mr. Why is it, I think I'm not at the level, why is it all over 3 if x was originally 4x?
Oh, because I'm silly. Thank you. Thought
I
ahead.
was going crazy for a second.
You're fine. I thought ahead and did the wrong thing at the wrong time. All right, and then what would the bounds be?
Negative 6 to 2.
Yeah, now you know it's all in terms of y. So the funny thing is in 6-1, that's where I really could have made, well, I sort of did. The dx dy decision controls everything after that, right? So this will be from, now I'm just doing it y, so I can just go from -6 to 2. And then I don't care, right? The rest of it is good. Okay. All right, so that's gotta be good, right? Who asked that question? You. Is that okay, or is that where you got to? Is that okay? No? I'm sorry. Did I do the wrong prompt? What happened?
No, you're good, you're good.
Is it, seriously, is it okay? Or is there an issue? Okay. You're like, stop looking at me, okay. Anything, yes?
Number 4B on the practice test.
4B? Okay. Yeah, this one's nifty. Immediately, let me just rewrite it as this. In the better notation, right? Minus, oops, I forgot the other part. Well, this part will be easy, should be 3x to the 3/4. Who cares about it? That's easy shit. This is one that's hard. So what I'm gonna do is, I'm gonna break it up into 2 integrals, because I got one piece that's easy, so I can just focus on it. The other piece is gonna need some help. Right? What is it screaming out? Why is this piece worse? Because it's a quotient, for one thing. Do we have a quotient rule for integration? No, shit! We do not. I can't just integrate the top and integrate the bottom. Of course, I can't even do that with derivatives. So I definitely can't do that with antiderivatives, right? So what do I use? What's the only other thing we have?
So-
Do so, right? So what am I gonna let u equal?
X to the 1.
And then what's du?
1/2 X to the negative.
Yeah, 1/2 x to the negative 1/2. Isn't that what this is?
Yeah.
Basically, except for the,
Just need a
what do you call it, the constant, right? So I need a 1/2 to show up, correct? So what do I put on the outside? So I can put a 1/2 inside. Yeah. So now this is du. Oops. Check. By the way, I'm kind of happy I did that. Do not forget this poor little dude, right? And don't forget him when you're doing an integral. This doesn't mean shit without that.
Why did you take 1/2 out for du?
How did I take it out?
Or no, not take it out. Why is there 1/2 for du?
Oh, okay. So, so du, what do I need to be able to see in here so I can put a du in its place? I need to be able to see this, this, and this. I can currently see this and this.
But where'd the 1/2 come from?
I put it there.
Oh,
I need it, so I'm gonna put it there.
okay.
But if I put it here, what makes it legal to do that? I just suddenly changed the problem. I can't do that.
Oh.
So, no, I didn't. And
I don't know where you got it from, is the thing.
okay, all right, I need you to.
It means from the derivative.
Yeah.
I
listen,
know.
listen.
Yeah.
So that's there, no problem, right?
No, but like, where did it come
No,
from?
no, no, no.
No.
That is here, no
Uh-huh.
problem, correct? Because I
Okay.
just did a derivative, right? So the
Oh.
1/2, is that really? Okay, okay.
That's
I wanna
also
make sure
where
I
did it
get-
come from?
What just came down, bam.
Okay.
All right.
I got it now.
So you're cool with the, if I need it, I
Yeah.
can put it in there, I can just balance it.
Yeah.
All right.
There we go.
Sorry, I wasn't sure what I.
What it was asking, yeah, I get
Yeah,
it.
so, this little cashew nut of stuff is du. And then this, of course, will be e to the u. Minus the other integral, which I don't give a shit about seeing. And then that's basically the most beautiful integral you can hope for, right?
E to the u.
Yep, and you just put u back in, right? Crazy,
Is that,
crazy
is
stuff.
that the times or minus?
Say it one more time.
For e to the u du, is it an e to the u times d to the u? E to the u times du?
All right. This can be looked at several different ways. When you're just doing an integral and antiderivative, I look at that as one symbol. Everything I just crinkly underlined is one symbol. Now we know when we're setting an integral up, this kind of thing could mean the width of a disk, right? Or the width of a rectangle that I'm gonna rotate, all this kind of shit. But once the integral's set up, this and this will disappear once you do the integral, because they're just part of the symbol. You guys see what I'm saying? What is the integral of e to the u? Du. E to the u. Did these go away? Not really. You did what they wanted you to do, so of course they're not still there, right? They both are there and they both disappear, because they both are part of one process. Minus, who gives a shit, and then you put the u back in. Is that cool? Is that fine? Anytime it's not cool, but I just sort of stop. Let me know, because I remember I did that and I was like, is everybody cool with that? And then I got people like, he doesn't do all this shit. Just tell them. All right. Anything, well, hopefully there's a lot more. I was gonna say anything else. No? All right, bye.
For number 2, for the using the f-talk 2 stuff.
Yes.
Well, are you gonna write down the like I stuff
Yes.
on the board?
Yes. So if I ask you that kind of question, I will give you the I stuff. Well, I mean, that's only fair, considering I think I do now, but I'm still not gonna make you memorize it. I never make you memorize stuff that I don't have memorized, and I could never memorize sum of I squared. I think it was, but now I think I could if I needed to, but I'm not gonna make you guys do it. Sure.
That's what you guys are talking about.
Ah, okay.
Oh, this is the review day, right?
Huh?
You do a disk problem?
A disk problem? Sure. Okay. Is that one a disk problem? let's see. Blah, blah, blah. Yes, why don't we do 6F? Because that's one that's different on the answer, because that's one of these that I changed the problem. Let's see if you agree with me about 6F being a disk problem. So 6F gives you basically this controls all of 6. So the very first thing we're going to do is going to be what?
Make them equal to each other?
Yes, find out where they meet. Right? Now part A actually gives you x equals 2 to x equals 4. So you have to be careful if they cross in there, then you have to take that into account. So let's see where they do cross. So if I set them equal, can you guys, if I set them equal to each other, I'm going to subtract one of them, so I'm just going to subtract these. 2x squared minus x squared, negative 3x minus negative 3x, 2 minus 6. Do you guys see what I'm saying? If I set them equal, I end up just subtracting one of them, so just subtract them where they sit. And then of course from there you get
Plus or minus 2.
plus or minus 2. So for example, part A says from 2 to 4. Will they cross within 2 to 4? No, they meet at 2. So you don't have to worry about setting up 2 intervals from 2 to 4 because there's nowhere that they cross in there. Does that make? I know where they cross. Do they cross where part A wants me to look? No, they cross at 2 and negative 2. They don't cross between 2 and 4, so who cares?
If they did cross in between the interval, which you have to do the thing where
You'd have to do 2 separate intervals, yeah, because then the top bottom function switches at some point. It's almost kind of like a piecewise idea, yeah. But not really. So what points are these? What do you get when you plug a 2 in? 4. So what do you get when you plug a negative 2 in? 4. That's right. Good. Because it's got square. No. Yeah. Because is that true, John?
No, I got a 16.
All right. Maybe not. What do you get when you plug a negative 2 in?
16.
So you get 8 plus 6 plus 2. Yeah, 16. Okay. Gotcha. So I know that's where they meet. So I just need to plot those, and then all that matters is connecting them to show me which one is on what side, if that's true. Now this is going to be a little bit strange. Let's see. So I got 2, 4. What should I make this scale maybe? And actually, to be really honest, I kind of want you guys to understand, I don't care. Is that a good scale for like chapter 4, for example? That scale is dumb. Should be negative. Oh, I got it backwards. All right, let's try to do this. I don't know why I thought it was negative. There you go. 4 and 16, right? Okay. Is that a good scale? Hell no. But again, the purpose of what I'm doing is just a sketch. Right. So negative 2, 4, and negative 2, 1. Sorry. Jeff, what's up with your negatives? 2, 4, negative 2, 16. I'm just trying to make everything negative. That's very nihilistic of me. Now all that matters is how these connect. All that really, really matters is who's on the top, who's on the bottom. And I know whoever's on the top in one place is at the top for the whole thing. Does that make sense? So I just got to plug a 0 in to both. So what do I get when I plug a 0 into the first two? 6. All right, so let's do him in green. All right. I just got to leave. Let's do him in purple. Let's do him in blue. All right, I definitely have blue. Wow, what did I not get enough of this morning? I had coffee. I had Okay, I'm feeling fine. I'm feeling fantastic. Alright. So 0, 6 for this guy. And then the other guy is going to be 0, 2. So they're both parabolas. Let me do him in red. All right, how do I say this? You could figure out where their vertices were, but it really doesn't matter. All that matters is the blue guy is on top, red guy is on the bottom. Okay, you guys kind of with me? Okay. So it looks like it's probably gonna be some kind of banana again. Get a lot of bananas when we do this. Now, so I found out where they met, so I knew what to graph. So I got my region sketched. I'm rotating around what? Y equals -1. Okay. So what would disks require? Right, I should have asked you, what's the next step? We got to figure out dx, dy, and that depends on which method we think we want to use. What would disks need?
DX.
So shells would need dy, so which one seems to definitely be the way I need to go?
Discs.
Disks, because my functions are functions of x, and I really don't want to solve them for x. Right? All right. And again, so every step I've taken makes sense. Right? They give me two functions, say the region bounded. Okay, first thing is where the hell are they bounded? Graph it, and then you can step back and say, which method do I want to use? Right? If this would have been dy, I would have used shells. Okay, I like it. So for disks in this situation, what do I need to find? Inner and outer. I love it. So we got check. The x in this case. Right, it's one big circle minus smaller circle. Right. It's going to have empty in the middle because the function doesn't hug the axis. I like it. So, how do I figure out my inner radius?
Start from where you're rotating. Y
Everybody
equals
wants to do it.
-1.
I love it. So start from the axis, always, no matter which method you're doing. And the disk method, you keep drawing until you hit a wall. So what's the inner radius?
Gx minus.
Gx.
Yeah.
Minus 1.
2x squared minus 3x plus 2 minus, not 1,
-1.
-1. Yeah. And I really want you guys to see, sometimes you have to do it without applying what I'm about to do because it's just too much shit going on. But look at this. Isn't that 2x squared minus 3x plus 2? Isn't that one step further? So wouldn't you add 1 to something that represents the distance? Okay, I like it, maybe. Does that make sense? Right? If it was the x-axis, this would just be that far away. But now I've got to add 1 because of this extra step I gotta go. So the inner radius is 2x squared minus 3x plus 3. If I draw out from this to the next wall, the outer radius will be x squared plus 6 minus -1, so plus 7. It's all one step further away than if it would have been the x-axis. So you just have to add 1 to each function. So in this case, it's very in your face. It's really clear what's going on. Not all the time, but sometimes the axis is on that side, all this shit. You just take big minus small. You see big minus small in so many places in chapter 6. So this is gonna look like pi. It's dx, so what's the limits?
-2 to 2.
Yeah, so -2 to 2, 11. Right, this thing does so much work. And again, that's why I keep saying that's one of the most important steps. And now this is just kind of gross, right? Our outer, where'd you go, R? Right here. X squared, good lord, minus 3x plus 7 squared minus our inner squared. Okay, and this is the kind of problem I would not give you. All right, let me be sure you understand. I would not give you a problem that requires you to square a trinomial on the actual test. Right? On the practice test, I'm like, haha. On the actual test, I'm not going to do this because this is like busy work. Yes? Which I always hated as a student.
So you just make the practice test a little bit harder to scare us?
Or to give you better practice. Sort of like if you want to practice basketball, use a slightly harder basketball. If you get that sucker in, you're golden, right? It's kind of the idea of my practice. Anyway, this is where I'm like, I don't care. Because you just FOIL it out, right? It's just a big old polynomial with another big old polynomial. Put your like terms together. Integrate a polynomial is the easiest shit, right? Is that all right? You guys upset at me if I, yes?
So in that sense, like, discs are not that different from washer, because you're just doing the same thing.
Listen, yeah, that's why I said, they call it washers to make it sound as if it's something different, when it's really just a big disc minus a small disc. So that's why I call it discs. You just have to subtract 2 discs, what you do. But I always hate it when they make it feel like something brand new.
Yeah.
No, it's not. Sort of like with the linear approximation when it was really just a tangent line. Here's something brand new. It's not good. All right, is that all right? Yes?
When we found the radius for the outside function, did we just do like the constant one?
Yes?
Is that what you say?
Well, yeah, officially it would be this, right? It'd be the top, which is x squared minus 3x plus 6, minus the bottom, which is -1. Yeah, so you end up adding 1. Yeah. All right, I like it. Now again, just to remind you guys, 6F on the answer key, I had it at -2 instead of at -1. Are you with me? So for some reason I switched. I don't know why, to be honest. That makes no sense to me. Ask Jeff. So I would have an 8 here and a 4 there on the answer key. And to be really honest, I didn't do shit after that because I'm like, same thing I say to you now. This is the easy part. Yes. Yes. Could I make this 0 to 2 and double it? Look at the picture. Is it symmetric? No, so no, of course you can't do it. You can only do that if it's symmetric. So I highly recommend you don't do it unless you're absolutely certain. Yes?
Is this like problem number 21 in 6.1?
Maybe. 21.
Like,
That's got tangent and sine.
yeah,
Okay.
when you said like you can double it.
Oh! That has a chance to be, well, sine, okay, that would be, strangely enough, yeah, equivalent on both sides. Yeah, so you could start it from 0 to pi over 3 and then double it, because it ends up being the same area on both sides. Yeah. Because the nature of trig functions is they kind of repeat. So they have a high chance of having symmetries. Right? Okay. Cool. One thing about 21 though, they give you the bounds, but you still have to check where they meet, and they do meet, they do intersect in the middle. So one does come from the bottom to the top, so you gotta be careful with that. Which is where the doubling thing really helps out, then you don't have to worry about it.
For 6, if on A, 6A says the bounds are 2 to 4, do we just disregard that? Because the bounds here are 2.
No, I really want you to understand. 6F says specifically rotating the region between these functions.
Oh, okay.
6A says, I mean, because these functions don't just stop here, they keep going. So, I mean, here the red would keep going and the blue would keep going, and I just want you to do the area from 2 to 4.
Oh, okay.
Do that weird
So, for example, do you see how the red function would be on top now? So
I know.
now,
I was thinking for some reason, oh, we have to find the area of that little bit and then we'll have to switch, but no, it's just.
No. yeah, 1 point doesn't do anything to us.
Number 5 just needs one integral, right?
Number which one?
Number 5 on the practice list just needs a one integral.
One integral, yes. Yeah, sure.
I was kind of confused because it says it generates 200 e to the equivalent of 1 t dollars per year, where t is the number of years. And then it says find a formula for a total number of savings in the first t years.
So, yes?
So wouldn't that just be like a sum of that?
Yes, sure, yes.
So,
But how many years could go by?
it says first t, so
But how many could that be?
any number.
Any number, so like 0.000000001 years, right? Correct? You guys understand what I'm saying? So when I say how many years, you think 1, 2, 3, but actually it's 0.0001, it could be 11.135 so that's it could be the natural log of 7 years, right? It'd be a very strange thing to say, how long are you gonna be here? Natural log of 7 minutes. Leave now.
So would it be like, a summation symbol?
No, it would not be. Because we're better than that. You're better than that. What's the, so again, how can I split time up? I'm not getting into blank time, physics stuff. Can I split them up into infinitesimal amounts of time? Not kind of. We're not getting into this. So I can't use the summation sign. I gotta use the one that works for continuous functions. I have to use an integral, all right?
Yeah, I was using one.
So I am going to integrate from what to what?
0 to t.
0 to t, I love it. And what am I gonna put inside?
200 e to 0.1 t.
So there's a problem with what you just said. I cannot put the same variable that's here. It doesn't make sense. They have to be distinct. So this is a lot like f top 1. You just have to put a dummy variable in there. Because again, the function I gave you is t magic. I love that idea. Yes, it is. Sorry. Is t the letter magic? No, it could have been an x, it could have been a w, it could have been an a, it could have been a happy face. Right? So I'm just going to put a dummy variable in there for right now. Doesn't this function have all the same outputs as the function I gave you? If t equals x? Yes, they're the same function. Now that's the weirdest part about this problem. Right there. But these cannot be the same variable, or else when you make this a certain thing, then this becomes a constant. That doesn't make any sense. This has to be a function no matter what that is. Good.
Could you go through your line of reasoning to you read the problem and then you connected that to f top 1?
Once it be connected into f top 1.
Yeah.
In a way, like I just said, I had to set it up with a dummy variable inside, just
But
like.
why set it up like that?
What other way would you set it up?
I just mean how did you know to put the t on top
Oh.
put it inside of it?
Well, what's part A say? Find a formula for the total savings in the first t years. So I wanted the savings from what to what? From 0 to t. Yeah, I want to add up all my savings from when it starts up to some position t. I love it. So what is this integral? I don't need u sub. Please don't tell me you need u sub. You don't need u sub. You don't. What's the integral of e to something?
E to something.
E to something. But if I take a derivative, wouldn't a 0.1 come down like a chain rule?
Yeah.
So doesn't this have to be divided by 0.1? What's division by 0.1? It's division by 1/10, which is times 10. Yep. Does everybody see that? So far, I'm not done yet, obviously. From 0 to t. So if you try it, take the derivative, it'd be 2000 e to this times 0.1. 2000 times 0.1 is 200, so check. And then I just plug those in. What do you get when you plug a t in?
2000 e to the 0.12.
Crazy. What do you get when you plug a 0 in?
2000.
Yeah, 2,000 times e to the 0 is 2,000 times 1, so you get 2,000. So that is your savings function. So then part B should be easy. What's up? See.
I'm just like walking myself because the E, I understand it, but I kind of don't understand it. Like,
So right here, what I really did was this.
Because you do.
Because I want to kill the 0.1 that wants to come down because it wasn't
Yeah.
here. Yeah. But 200 divided by 0.1 is 200 divided by 110, which is
Oh.
200 times 10.
Got it. Okay. Okay.
Part B is now easy. Part B is now math 90, to be honest. I got a function, well, maybe not 90, with the E in there, math 110. I got a function, and I want it to equal what? What do I want that function? That function represents what? Savings. And in part B, I want my savings to equal what?
1000.
1,500. So just set that equal to 1,500, solve it for T. Right? That'll tell you how long it's gonna take for you to recoup the cost, right? That's the whole way to sell solar is, sure, it costs a lot of money to get installed, but eventually you're gonna be caught up, and then you'll be like making money instead of, not really making money, just not losing.
I have one question, but can you actually do it? I just wanna
Yeah, I
make
did it
sure
on the
I
key,
get
but I mean,
Okay, yeah.
what is this representing it?
My savings.
What is this oh, yeah, sure, savings, so I put 1,500 there. All right, I don't wanna write all this shit out, blah, blah, blah. So I'm gonna add 2,000, divide by 2,000, and then how do I solve for T? Is that cool? Add 2,000, divide by 2,000, right? Take a natural log, and then I'm gonna divide by 0.1. Just throw that in the old calculator. What'd you get?
Oh, no, I haven't done it yet, but
Okay.
I was just walking myself.
Gotcha, gotcha.
Where does the minus 2,000 come from?
What do you get? So you plug a T in, bam.
Okay.
You plug a 0 in, oh shit, this is what I told you, be careful. Don't just see the 0 and go, I don't have to worry about that. Unfortunately, we start with polynomials because they're easy. We want you to get used to the idea. But then polynomial stuff makes you think, oh, when I see a 0, it's always, no, it depends on the function. Yeah.
So wait, you just added 1,500 to both sides?
Yeah, no, I added 2,000 to both sides, right? I'm just solving for T. So I add 2,000, divide by 2,000, kill the E with the natural log, it's just solving the equation, right? You get all your not T stuff on one side, and then you free T up. Right? Then you drink the tea. Yes?
How much of 6.5 will be on the test?
Well, currently there's like one problem on it. I think it's not even one problem on here, is there? I forgot to even put one problem. Let me think. 6.5 was the average value. So like on number 6, I should have put a part G saying find the average value of F over this. I mean, 6.5, please tell me. There might be a couple problems that are a little freaky conceptual, but 6.5 has to be simple. It's find an integral and then divide by b minus a, right? So if you can integrate the number, you divide it by b minus a. Cool, right? Maybe? No? Some of you guys are like, dude, I am on 6.1. I don't know. All right. So let's do, while there's a lull, let's look at 4i, because that's one that I changed so the answer key doesn't match the one on our practice test. What is it now? 3x over 2. Yeah. So for some reason, I used to have a square here, which makes it a lot easier. And then I thought at some point in the past, I wanted to be evil to me and you, everybody. I just made it this. be honest, I love that, that's awesome. Good job, Pastor. Did anyone try this problem? I know somebody did. We talked about it. Anybody else try this problem? All right, stare at it for a minute. Can you understand why why would this be better? That's instantly easy. Why?
This derivative is in the.
Yeah, u equal the bottom, the derivative, that's basically the top, absent a constant, who gives a shit about constant? Easy u sub. Now one change, shit. Right? But what would you try? Let's try to do the same thing we would have done. Let's try to make u equal to what?
3x.
No.
That.
No. If it was this, what would you let u equal?
2 minus 3x.
2 minus 3x squared. The whole bottom, right? So let's try to make u equal to 2 minus 3x. Let's try it. I'm going to do it this way and then I'll show you another way. So what's d? Yeah, negative 3dx, right? So cool. Now why does it seem like that's no good? Do I see everything I need? Well, I do, but is that being replaced with something? Shit, right? Shit. So what do you guys remember what I can do?
Would you find x?
So I can solve this for x. Or I can even be smarter than that. So I can take this. I really want you guys to understand what's happening. That is u. If I put a negative there, this and this is du, right? So everything's in terms of u, oh, except for that guy, the damn guy. You need everything that was x to become u, or else the whole thing goes to shit. So the most basic, kind of like extra step to u sub is, the minute you write u as a function of x, you can solve for x. Then you know x is a function of u, right? So here I'm going to be kind of smart about it. I'm going to add 3x and subtract u, so I get this. Now why is that kind of cool? Because I have a 3x here, right? Now let's see, there's a couple of weird things about this. What's going to be the easiest to describe this right now? Yeah, I'll just do this. Let's just solve for x. Okay. Otherwise it gets that. You could solve for 3x because there's a 3x in there, but don't I need a 3 for du, so you'd have to kind of take care of all that? All right, let's just do it this way. So let's see. Anything I did here, not clear. Okay, so you get negative integral. Let's see. Negative 3 dx is du, yes? X is 2 minus u over 3, and this is u. Now somehow, that's better. Did I forget something? No. Okay. Somehow that's better. And the reason that's better, let me take this stupid thing out. Is that all right? Let me take this out. Do you see what I can do? I don't have a quotient rule, but I don't care, because now the bottom is one term. So what can I do?
Break it up.
Break it up. 2 over u minus u over u. Well, that kicks ass. What's the integral of 2 over u? Natural log of? Good. Look at that. Minus. Integral of 1 is u. Right. So then I get negative 2/3 natural log of, what was u? 2 minus 3x. Plus 2 minus 3x over 3 plus c. All right. So again, we've seen this before. The bottom is 2 terms, the top is 1. If I do this u sub where I solve for x, I can make the bottom become 1 term and the top 2. That's a much better situation, because now I'm allowed to break it up. So I'm kind of using U sub, and that's kind of a sideways method. Now, I can do this whole problem without U sub. Let's see if it comes out right this time. We never figured out why it was, well, we'll see.
Had something to do with the negative.
Something with a negative, I don't know, maybe it'll come out this time. Real quick. What was it to begin with? It was 3x. I think I'm gonna turn people off immediately with this, but it shouldn't be that bad. I can long divide this. Well, I don't know it's gonna work because they're the same degree. It's only at the top is smaller degree than the bottom, it's not gonna do shit. Let me do it like this. I'm gonna take a negative, maybe I shouldn't. Maybe because, yeah. Negative 3x plus 2 into 3x. All right, this is where I've already lost some people. You're all like, I gotta do that. This is easy shit. Negative 1. Because what times negative 3x is 3x? Negative 1. So I get 3x minus 2, change the signs. And then that's how I write the remainder, right? Look at that. I can integrate that. So now this becomes the integral of negative 1 plus 2 over negative 3x plus 2 dx. I get negative x. Let's see if we can handle this. This will be natural log of this. If I do this derivative, it'll be 1 over this times the derivative of this, so that'll be negative 3. I don't know if you guys are with me. Did I make it come out the right way this time? I don't know. Yes, I did. It did work this time. All right. I don't know what I did the first time. All right, I understand. I kind of am shitting on this as I do this, but I don't know if anybody, you can always do this. If the degree on the top is equal to or greater than the bottom, you can long divide. It's always an option. But I understand that most of us would say, no thank you. But that was quicker, wasn't it? That was quick. I didn't have to do use of it all. Yes?
So we have to add plus C because it's an indefinite.
Indefinite, exactly. Now, real quick. Do you guys see right here, this is negative x? Isn't that negative x? Check. Isn't this negative 2/3 natural log? Right? But look at it, 2/3. Do I have 2/3? Do I have 2/3? The number 2/3. Do I have it over there? But I'm saying these are the same. These are exactly the same. Because isn't this just a constant? Couldn't I suck the 2/3 into it? Right? Whatever my constant is, yours is 2/3 less than that. It's just a stupid constant. Anyway, that's too much. So depending on the method you use, you could come out with a slightly different looking answer, but it's just going to be off by a constant that could get sucked into this guy. I don't know if that makes sense. Yes?
You said it only works if the terms are the same, or what was it?
If the degree on top is at least as high as the degree on the bottom. So, watch. Could I divide that and get a whole number answer? Well, no, I'm sorry, not a whole number answer. Could I divide that and get an answer that's at least 1?
Yes.
Could I divide that and get an answer that's at least 1?
Yes.
Yes. Could I divide this and get an answer that's at least 1?
No.
No. So this is the degree is the same top and bottom. This is the degree is higher on the top. This is the degree is lower than the bottom. It's kind of analogous. So the degree was the same, meaning I should be able to long divide and get a meaningful answer. Maybe. Okay. Again, you don't have to do that. You do it this. But look how quick that was. I'm trying to So again, 4i and 6f are different on the answer. So just be careful. So that's why we did both of those. I don't know if everybody can see all of this. There we go. Bum, bum. Okay. Anything else on this practice test or homework? You guys want to do a shells problem? Alright, does anyone know which part of 6 is a shells from? E. Why?
Let's do it with respect to the
Line x equal -2 is parallel to the y-axis, which requires dy, which we really don't want to do. Okay. So I'm gonna require your help real quick, or I can just sneak a peek at the key, just to recreate the region again, right? The region was like, wasn't it -2 to 2, if I remember correctly? Wasn't like this. And then 4 and 16, is that the one that was?
Yeah.
Yeah. And it was,
Negative 260.
yeah, okay. And then it was, basically, oh yeah, 6 and 3. So this,
6 and 2.
this, 6 and 2? Whatever the shit that is. Alright. That's terrible looking, but oh well, too bad. Banana's been sitting out for a while. So I want to rotate around x equal -2. So I want to rotate around here. So I'm going to get some really funky looking, I don't know if you guys can see it in your head what that's going to do. You rotate it. But you take that, and you rotate around, it's going to be some really funky looking thing where the inside goes like that.
It's gonna be a really
Like a hat.
frisbee.
Huh?
It's gonna be like a really weird.
Yeah, maybe it's some frisbee that actually is aerodynamically better. Who knows? We're designing frisbees here, everybody. Okay.
It could be a hubcap.
Totally could. So we identified it as shells because disks would require dy. And my functions are in terms of x and I don't want to solve them for x. So I'm going to use shells. So what would shells? Shells, if I just write down the basic idea. Yeah, they're pi. In this case, it was dx. So yes, you have to memorize that. Right? So disks are built around pi r squared. Those are just areas of disks. Shells are 2 pi rh, because that's the air and surface area of a cylinder. Okay, I like it. And if during the test you're like, ah, shit, just come up and say, was it this? And if it's good, I'll say it's good. If it's bad, I'll say you're almost there. You're missing something, right? I'll give you a little in the right direction. So now I know, so I identify what this is, what this needs to be, so then I can tell which method to use. Then I write down what that method requires of me, and now I focus on that. Now what do I want to draw on my picture to help me identify the parts? Draw a representative incongruous. No, representative rectangle, right? Is it going to be standing up or laying down? Standing up. Why? It's got to be parallel to the axis of rotation. I love it, right? Because it wants to be standing, so it can go around it, make a nice shell. So you can draw it anywhere you want to. I'm going to draw in the meaty part of this banana. I know that's really gross. The meaty part of the banana. What is me drawing that does everything for me? How do I locate, so it could have been over here, it could have been over there. How do I locate my rectangle?
It's an x value.
The x value of the rectangle. That's how I look, because I can move along the x-axis, and again, that tells me I locate my stuff. So then I can get the radius, yes? And again, how do I get the radius? I want to know this distance. What is that distance? What's the bigger one between these two things? What's bigger? X. So the radius is going to be big minus small. You see how often that big minus small idea comes up? Because I need the radius to be positive. What would a negative radius be? I don't know. Starts at the center and goes, yeah. I don't know what it is. You start making black holes, right? Okay. So the radius is x plus 2. What else do I need? The height. And now that you've drawn the rectangle for yourself, because you're being nice to yourself, you just look at the rectangle. So every step is its own little problem. How tall is that rectangle? I don't know, what was the top function again?
X squared minus 3x plus 6.
X squared minus 3x plus 6, right? And the bottom one,
2x squared minus 3x plus 2.
and I know that because 6 is bigger than 2, that's why it's 6 and 2 here. Okay. So what's the height of this rectangle?
X squared minus 3x plus 6.
Yeah, the top minus the bottom, so let's just go ahead and take the difference, is that cool?
Yeah.
Negative x squared, you guys see what I'm doing? Right, I'm gonna do this minus this. Get the height. Negative x squared, these cancel, plus 4. So now I've got 2 pi integral, we're gonna worry about these in a second. Radius is x plus 2. Height is negative x squared plus 4, so I'm just gonna put 4 minus x squared. dx, and of course, what are these?
Negative 2 to 2.
Negative 2, because that's dependent on x, so it matters what x is. And of course, that's where I'm going. And now you just FOIL, you got polynomial, do you see? There's no way in hell you can get a problem and know what this is going to be just by looking at the problem. There's no way. You've got to build, draw the region. Where do they meet? What's on top? What's on the bottom? What would disks need? What would shells need? Which one is going to work better? Then write down what that method requires of you. And then you can focus, okay, I need this thing, let me focus on that. I need this thing, let me focus on that. Plug all the shit in. Right. I still think that students feel like you're supposed to just be able to do it all kind of at once or something, I don't know. And that's insanity. Right. Maybe? No? Is it any better about the radius now? I mean, you always just start the axis, draw out, I want to know what that distance is. That's it. So whichever one's more in the positive direction if you're doing x or y, start there minus the other thing. That's it. Okay. Blah, 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 blah. And again, could I make the 0 to 2 and double it? Why not? Let's measure it. This is definitely one of the funkiest things in Calc 1, for certain, this year. For me, when I took calculus, this was actually in Calc 2. And they just reorganized how we did things. And I think I told you guys, I sucked at this. I sucked at this when it was taught to me because it was barely taught to me. So I'm hoping you guys will be better at it. I'm like, please tell me I'm not as bad of a teacher as my teacher was. Dr. Fanner, you were fine. Dr. Fanner, you just had problems with that one thing. That was my teacher's name, by the way, Dr. Fanner. So. Anything else specific or general?
I'm just still iffy about using chain rule
In
in
what capacity? Like just the chain rule for derivatives?
No.
Or chain rule for the new derivative of an interval? Is that kind of like where you're,
I think so.
like, did I put a problem like that on here? I should have. Yeah, like number 7?
Maybe, yes.
Maybe? Okay. What is it? T squared to x squared to 5. T secant squared of t. And I want to know the derivative of this. Is it in the correct form? No. Right? And that question is the same as if I had 1 over the cube root of x. Is that in the right form? No, I could put it into x to the negative 1/3, and then I can do it, right? It's the same question. The form it needs to be in is, this should be a constant, this should be a function of x, right? So how do I do that?
Flip them by adding a negative.
Jeff? That's just the way today's gonna be. So now it's in the right form. the rule of derivatives of integrals say that goes in here. But what's the inside function of this? X squared. And whenever the inside function is more than just x, I have to use chain. Right? So if this would have been just an x, the answer would have been x secant square root of x. Negative. But that's not what it was. Damn, too bad. Right? So the rule is, plug whatever this is in. Okay, that's the first thing. That's the rule for any derivative of an integral. But then, the inside function gets a term. That's the chain rule piece. Right? So if this would have been just x, then it would have been just x is there without that. Okay. All right, so then you can write this as negative 2x cubed, secant square root of x squared, and of course this could be, what is the square root of x squared?
X.
No. Nah.
X.
Nope. I love it. Now you guys are like, dude, earlier you called freaking blue, you called it green, so I don't know if I can trust you now. What's the square root of negative 3 squared? Definitely not. Square root can't come out negative by definition, right? What is negative 3 squared? What's the order operation say? Don't you do the inside first? What's negative 3 squared? 9. What's the square root of 9? 3. So did these just cancel? No. In fact, it became the absolute value of that. Real quick, watch this. I want to make a connection for you that I bet never's been made for you before. How would you solve this again? Square root and have to put what? Plus or minus. Watch this. If you could do this a different way, square root of x squared is the absolute value of x. Doesn't this mean x equals 2 or negative 2? So that's a whole other reason why there's a plus or minus there, because square root of x squared is the absolute value of x, which leads to 2 outputs. Okay. And again, I'm not yelling at you. I don't think you were probably ever shown this. Okay. All right. Let me give you the answer key. And again, 4i and 6f will be different. I think it's 2 parts to it. No. 2 parts to it this year.
Oh.
Crinkly one.
Get the one with personality.
That's your both yours. Got 2 pages.
Thank you.
Just double check, make sure you got 2 distinct pages, right? Just in case I mix these up. So one more time, just take a quick second and cross through 4i. That's on the back of the first page. And cross through, and 6f I really didn't do shit, but cross through it. You can see where for the old practice test, it was why it was negative 2 instead of negative 1, right? But now you weekly those together, so you got the right answers. I love it. So double check my answers. If anything looks wrong, let me know. I am still human, and I am still averaging about a 97 on my answer keys. Yes.
What was the second one you wanted?
There was 4i and 6f.
Okay.
So we did those together. On the answer key, they're different problems, so they're not going to match up. You see how like on 6D, I just was like, oh, screw it. So I'm not going to do that to you. So I'm like, I'm not going to do that to myself either. So to be really honest, I just plugged in the calculator and got the answer, but I'm gonna give you simpler ones, so you have to actually do it by hand, right? I'm not gonna make you FOIL a trinomial, yes?
For the number one on the practice test, what's like our margin of error? Or like, how far can we be out?
What, sorry?
For number one?
How far can you be off? What do you mean?
Our estimation.
What'd you get for A?
What do you mean by
Are you asking me, like, your answers for number one? How different can they be? Is that what you're asking me?
Yeah. You
So-
know, like an approximation using the sketch.
Do it again, sir?
Isn't it like an approximation using the sketch? Like how we did on the quiz?
It's an approximation, but you know the function, so you can get the values.
Oh, without using the sketch.
Yeah, don't just look, just, I gave you the function, so you can actually get what f of 0 is, what f of 1 is,
Right,
right?
so we won't have to sketch anything out like that.
I'm not saying that. If I gave you a problem where you had to estimate, I would give you the graph with like detailed grid, so you can kind of really make good estimations, right? But here we know the function, so we just plug in, yeah. And by the way, do you notice how number one is 3b? So you see how on 3b on the answer key I said compare to 1c? So the actual answer is 2. And on 1C, when we average the right and left endpoints, I got 2.057. That's pretty good for
okay.
just, what was it, 4 rectangles? Is that cool? Okay. People have trouble with 4E for some reason. So don't look at the answer key, look at the problem. 4E. Did anybody try that one yet?
Okay, which one?
4E. So it's the integral, what was it?
1/10W VW.
Yeah. I don't know why this trips people up. Why is this not correct?
Because when you take the derivative, the tensor
Yeah.
cancels out.
Yeah. So I mean, you can actually do this one of two ways. That's not the right answer because the derivative would be 10 times 1/10W, which would be 1/W, which is not what this is. So that just means you want to divide it by 10 to kill the 10 that wants to come out. Or from the beginning, you could take a 1/10 out, and this is 1/10. What's the natural log of W? Now, why are these the same? Oh, that's a good question. My argument is those are the same thing.
Because one
Because
times
it's
is a constant.
1/10 times everything or everything times divided by 10.
What's true about this? What can I do anything with that? Natural log of A times B.
You can break it apart into addition.
Yes. So then what's natural log of 10W?
Natural log of 10 and natural log of W.
And this is a constant that can get sucked into this guy, so these are the same. Stop it. And by the way, oh my God, okay. Holy shit. A couple things while I'm thinking about it. What would this be? How would you do that? Is this the natural log of x squared? Yay! Fun times, I'm done. Shit, no! Hell no!
Would it be 2 natural log of x?
What's the only thing that leads to natural log? 1/x, or something like 1/first power x stuff, right? Integral of 1/x minus 3 would be natural log of x minus 3. That's you got it right. Because it's to a first power, so it's x to the negative 1. That's the one thing that doesn't meet this rule, is if n is negative 1, right? If n is negative 1, you're divided by 0. So that, no freaking way. So you can't just say natural log of shit on the bottom, and then the next problem, natural log of shit on the, this is easy. People said calculus was hard, this is easy. No, that's bad. How do I do this? How do I rewrite 1/x squared?
X to the negative 2.
Right. Right? So be careful, don't just natural log everything. Yes?
So like 1 over x plus 3, just to clarify, that's like natural log of x plus 3.
Yep, totally, all day long. I do like doing problems like number 6 where you draw a region and then do multiple things with it. Because it just, drawing the region is what kind of takes the time for some people. So if I just make you draw it once and then you can do multiple things to it. All right, so we'll see if I do that. I do like doing it, it doesn't mean I'm going to. So be ready. It wants to be.
Okay.
Well, what's it say? It'd be x to the new power divided by the new power. So it's negative x to the negative 1. Because when you take a derivative, the negative comes down, you want a negative there to kill it because the original was positive. Yeah. So it's always, something I still don't quite get how simple any x to a power is. X to any power. So what about x to the a dx, where a is not negative 1? A is something not negative 1. What would that integral be?
X to the a plus 1 divided by a plus 1.
Yeah, it's basically the rule, right? But the idea is, what about x to the 1.7? Integrate that. Easy as shit. What's the new power?
What's that?
2.7. Then you just divide by the new power. That's the rule. Raise the power by 1. Whatever you just got, divide by. So if it's a fraction, you multiply by the reciprocal, because that's what dividing by fractions does. So what's the integral of x to the 81 over 103?
X to the 191. Oh wait, no, x to the 184.
184, there we go. Remember the shortcut, just add the damn things, right? Because when you add 1, which would be 103 over 103, so you end up adding 103 to 81, so the shortcut is add the damn things, right? Times 103 over 184, there you go, that's not very bad. So if you can integrate 81 over 103, you can integrate freaking x to the 2 fifths. No problem, yes.
So, like, let's say we have to pass a fraction into an integral, we'll never distribute that fraction to the constant, right? The constant will always just come at the end.
Oh, that's a good point. Earlier today, I actually put the plus c outside of, like, there was a negative 1/3 in front of shit, and I put the plus c out there.
Yeah.
Because if I put it inside, I would actually have to make it c1, because then when I multiply by this, it becomes some other constant. So I just put the plus c, now listen, if you do get to differential equations or some higher level math course, the plus c becomes stupid important. Stupid. Even right now, if I integrate something twice, don't I pick up a plus c and then I'll pick up a plus cx plus d? So don't I have to keep track of different kind of constants if they show up at different times? So in higher level classes, you'll actually have like a plus c1 and some plus c2 and a blah blah blah. And these can't be put together. They actually won't be combined, but this will be y1, this will be y2. And these will be different things. You have to keep track of which one's which. But right now, it just everything dumps into the plus c. Any constants just get dumped in there. Okay. Maybe. So that's a good question. All right. But yeah, real quick, if I had like 1/2 integral x, yeah, sorry. What would that be? Maybe like this. If I do that, then I'd have to do this. Because what's 1/2 of c? I don't know, I'll call it d. Or you could just do this. But that's kind of frowned upon.
But in that case, it doesn't really matter, right? Because you take the derivative, c is a constant, so it just goes away, right?
True, so that's why instead of doing this crazy ass thing, I do that.
Okay.
because all the constants get dumped into one place, so don't make multiple constants and then have to come up with D and then E and then F. No, just everything gets dumped over there. That's how it is right now. Like I said, when you get to higher level math courses, you're a little more careful about your constants. I think we hit most of the exceptionally weird shit. Let's see. Yes?
Just a quick thing on 4H, because for part of your answer, you got 5/22. It should be 5/27.
There we go. I was like, where are my other mistakes? There must be other mistakes. Oh, that is a 7, believe it or not. It looks like a 2, I totally agree, but it's a horrible 7.
Okay.
By a lot of line through the 7 got a little curve to it. It looks like a 22, that's evil. So it is 5/27, right? Yeah, that's what that is. So for H, it's 5/27, even though it looks like 5/22. Thank you.
Thank you.
That's the horror of having a teacher that can't write to save his life. And who, but you know, I prefer to do this than give you just like the answers without the solutions, right? Would you rather have that? You could read them real nice on a computer. I could just do them on a computer, just the answers. That'll make my job easier. Shit. What's this? Oh, how would you do that? Say again.
That's a big constant.
Sure, yes. So how would you do it?
And we just had an X.
So the integral of constant is the constant times x. Right? Blessing. So yeah, this is a big ass constant, yes? That's just the constant. So how do you integrate a constant? Just throw the variable on it, right? Integral of 5 dx is 5x plus. Good. So it's sort of like 4C's older brother, right? Yes.
On the exam day, would you be willing to let us know when like we're halfway through our allotted time for like pacing?
If I think about it, you know our allotted time. There's a timekeeper.
I don't know, what's up with that?
Huh?
I could just hear you say it.
Oh, all right. If I remember. Tell me at the beginning of class to set an alarm for my time. Because otherwise I'm not going to think about it. Like, oh yeah. You have 2 minutes left. All right, we're all ready. We can head out. No reason for us to sit here staring at each other. Oh, by the way, I need to, all right, so after this test, on Monday, I'll give you an updated grade sheet summary. It'll have on it my final exam week schedule. This is gonna change, because everything changes. But also, I'm gonna send you an email because next week, I don't know if you guys know Corey Manchester. So I opened up, we might have more people in here for our final review because I just opened it up to all the calculus students to come if they wanted to. And Corey did the same thing. So I'm gonna email you his details, so if you wanna go to his calculus review and mine, then it could be like, oh man, why didn't I take him from the beginning? He's awesome, yes, okay, that could happen, which is great, go get help. So I'll let you guys know if you want extra review from a different perspective. Okay. Cool, all right.